let's first look at the angles in the same segment theorem. So if a circle is split with a chord, so there's a difference between a chord and a diameter. Diameter will always go through the center of the circle. A chord will not. It will just go from one end to the other, but will not go through the center. So, and it will split the circle into two segments. We've got a segment here and a segment here. If we were to create an angle in the same segment, the angles will be the same as each other. So if we were to create an angle and then a second one, this angle and this angle will be the same as each other. Now, very likely that in an exam question, you won't get this chord, so you'll get something like this. Again, these two angles will be the same, so will these two angles, as long as they're all in the same segment. Now, if we have a diameter, if we draw the diameter, again, might be doing it a bit rough, but if this is diameter, we know the angles in the same segment will always be the same as each other. So if we were to draw angles, let's say we go here, this one, and if we were to draw another one, these two angles will be the same as each other. However, if the line that's splitting the circle into two happens to be the diameter, and it generates a semicircle, the angles in that semicircle will always equal to 90 degrees. Always and always. The next theorem, if we draw a chord and create an angle at the circumference, and then using the same chord, we draw another angle at the center rather than the circumference, the angle at the center will always be twice the angle at the circumference. So let's say this is 50 degrees, then the angle in the center is always going to be 100 degrees. Or we can say it the other way around, the angle at the circumference will always be half the angle at the center. For the next theorem, we're going to look at a cyclic quadrilateral. A cyclic quadrilateral is a quadrilateral where all the sides will touch the circumference of the circle. In a cyclic quadrilateral, opposite angles will always add up to 180. So angles 1 and 2 will equal 180 degrees. Angles 3 and 4 will always also add up to 180 degrees. Altogether, there will be 360 degrees in a quadrilateral, as we've already mentioned before, but the opposite angles of a cyclic quadrilateral will always add up to 180 degrees. The next theorem, we'll look at a tangent. So a tangent is any line that touches the outside of a circle. Now, a tangent will always meet the radius of a circle. Radius is from the middle of the circle to a side. A tangent will always meet the radius at 90 degrees on both sides. Now, for the next theorem, if we have a tangent, if we have two tangents, so meet at the same point outside of the circle, so this tangent meets this tangent, let's say at this point here, point P, from where it touches the circle, from the 2 points where it's touching the circle, this length is going to be the same as this length. So these two lengths will be the same as each other. However, it might not be demonstrated using arrows, but these two lengths will be the same as each other. And if we have a line from the center of the circle to point P where they meet, this angle will be split into two. So if it was originally 50 degrees, then this is going to be 25 degrees, and this is also going to be 25 degrees here. For the last theorem, we're going to draw a tangent. We're also going to draw a chord, which results in an angle here. Now, if we use the same chord to create another angle, but in the different segment, like this angle and this angle are going to be the same as each other, which is referred to as the alternate segment theorem. This will also apply to the other angle, so this chord will create an angle with a segment here, the angle in the opposite segment over here is going to be the same as this angle. So the two green angles will be the same as each other, the two blue angles will be the same as each other as well. Hope that makes sense. Let me know if you've got any questions. In the future videos, we're going to look at how we can apply each of these theorems to an exam question. Let me know if you've got any questions.